Okay, so you must be well aware about the achievements which is happening within the country by Department of Space and ISRO in particular. India is now a well-recognized spacefaring nation with its own rockets launched from its own soil, carrying its own satellites in space, but not only in space around the planet Earth, but also to other planets in our solar system. So my talk will be more concentrated on what kind of planetary missions has India has undertaken and what we plan to do in future. Okay. Now, before that, let me tell you a little bit about PRL. In particular, that PRL is an institute which was established by Dr. Vikram Sarabhai, and it is called as the Cradle of Space Science in India. And I will tell you in a while why it is called the Cradle of Space Science in India. This institute has 4 campuses. The one you are seeing in the bottom, the main campus in the bottom left. In the middle, you see the Thaltej campus, that both of them are in Ahmedabad. Then we have Udaipur Solar Observatory, which is in an observatory to study the sun in the middle of the lake, which is called the Fateh Sagar Lake. And then we have an observatory in Mount Abu, which is called Mount Abu Observatory. So there are 2 big observatories which look at the sun and also the stars and planets and galaxies in the beyond the solar system. PRL was established in the year 1947 by Dr. Sarabhai. And we are now celebrating the Platinum Jubilee of PRL because along with India's independence in the year 1947, PRL also got established in the same year. We have celebrated the birth centenary. Hello? Hello? Is there any issue?
No, sir. No, please continue, sir.
Okay, thank you. So we celebrated the birth centenary of Dr. Sarabhai 3 years back. And currently we are actually celebrating the Platinum Jubilee of PRL. And we have started a series of Vyakhyans, which we call as PRL Kamrit Vyakhyan, which is happening every Wednesday at 4 p.m. So all those who are listening to my talk today, you can go to the YouTube channel of PRL, which is given in the bottom, and look at all the Vyakhyans which has happened so far. We have conducted 43 Vyakhyans consecutively every Wednesday at 4 p.m. And in the future also you can come online and even ask questions. Now, as I was mentioning that PRL is established by Dr. Sarabhai, who is of course the founder of Indian Space Program, the founder of PRL, and of course a well-distinguished space scientist. And he established it formally in the year 1947, precisely on 11th of November. It actually started in his home, which we call as retreat, which you see over here in one of those slides in the bottom. And then it moved to NG Science College. And then we have the first council meeting where you can see the gentleman standing is none other than S.S. Bhatnagar himself. And then we started observations at Mount Abu in 1951, particularly the ozone measurements. Foundation of the PRL was laid by Sir C.V. Raman, the Nobel laureate, because Sarabhai used to treat or used to consider Raman as his guru. And that's why he called guru to actually lay the foundation of PRL. And in 1954, the first building of PRL was inaugurated, which you see in the top right side. And it was done by then Prime Minister of India, Pandit Jawaharlal Nehru. Subsequently, the multi-story building came up, and this is how it looks last year on 15th of August. Also have a second campus, as I was mentioning, in Ahmedabad, which is called as Thaltej campus. And then the 2 observatories, the Udaipur Solar Observatory and the Mount Abu observatories, which came in 80s. Now, talking about this logo, I hope many of you must have seen this logo of PRL. But what does it convey? If you look at this symbol, which is on the right with a cross in the center, this is the symbol of the Earth. Then another circle with a center dot is the symbol for the sun. And now both the circle are encircling a big circle. And if you translate this, what does it mean? It means PRL research encompasses the Earth, the sun, immersed in the fields and radiations reaching from and to infinity, all that man's curiosity and intellect can reveal. So essentially, if you convert this, we study everything on the planet Earth to the sun and much beyond. So that is how the science of PRL is. And if you classify this kind of science which you do in PRL, you can say we work in astrophysics, we work in solar physics, we work in space and atmosphere science, we work in atomic molecular physics, theoretical physics, geosciences, and planetary sciences. And we have a very strong and vibrant students program. Almost like 120 students are there at given point of time in the campus. So the focus is to do international competitive research. And if you look at how does it all evolve in PRL, it started with Dr. Sarabhai. So cosmic rays started, and the first director of PRL was Professor K.R. Ramanathan, and his expertise was in atmospheric science. So that's how the cosmic rays and atmospheric sciences started in PRL. And then we added theoretical physics, radio physics, earth and planetary science, infrared astronomy, and plasma physics in 60s and 70s. And that was a time when INCOSPAR, a committee to look at the space science research in India, started in 1962. The formation of ISRO happened in 1969. And after the demise of Dr. Sarabhai in 1971 December, we have the formation of Department of Space. Then we added plenty particle physics, solar physics, laser physics, quantum optics, nonlinear dynamics, astroparticle physics, and cosmology. And the work which was started in 80s in plasma physics grew much larger. And then it became an independent institute, which we call as Institute of Plasma Research. And this Institute of Plasma Research is now under Department of Atomic Energy. So we continued on to expand the domains of research in PRL. So we started solar astronomy, planetary exploration, particularly with the Chandrayaan-1 mission, and then astrochemistry, photonics, planetary instrumentation, and exoplanetary studies. And I will tell you a little bit about that. And then, of course, the space weather, studying the sun and earth connections. And in the last 1 decade, we have now added shock processing of ice, quantum communication in particular, as ultra fast processes, happening at femtosecond and attosecond scales, and artificial intelligence and machine learning, and solar radio bus studies. So that is how the growth of PRL has been. And many of them is actually connected to different programs of the Department of Space, ISRO, and of the country. If you look at how PRL has actually contributed in national branding, Professor U.R. Rao, many of you must be familiar, was an alumni of PRL. He did his PhD with Dr. Sarabhai, and of course was the chairman of ISRO and Secretary Department of Space. Dr. K. Kasturirangan is a PhD student of PRL. He did his PhD here, and then very well he went on to become the Secretary Department of Space and Chairman ISRO. Dr. Kalam, all of you know very well, right? The President of India. He was actually working in PRL when Dr. Sarabhai gave him the job to go to Thumba in Trivandrum and start the rocketry program. And then many others whom you are seeing over here. Probably you can note down their name and find out why they are famous. Okay, so this is a job for you. We say PRL is a cradle of space science in India because all the activities actually started from PRL, because Sarabhai ji knew that we have to grow the space research and space sciences in the country. And that is how he started the rocketry program in Thumba, and there Dr. Kalam was sent. And then he started the satellite program in Bangalore, where Professor Rao was sent, along with the Dr. Kasturirangan. And they all started the satellite program in Bangalore. And we have the first satellite Aryabhatta, which actually carried instruments developed in PRL. But if you talk about the first rocket launch from Indian soil, that is on 21st of November 1963, it carried instruments developed in PRL. So PRL is actually contributing to space program in a big way right from the inception. Now let me talk more detail about planetary sciences and planetary missions in particular, because as you must have heard about the name of Chandrayaan-1, Mangalyaan, Chandrayaan-2, and missions like that, or even Aditya L1 you must have heard. So I'll give you a little bit brief about this kind of missions which India has undertaken and which have been very, very successful. As I just mentioned that we started the rocketry program in 1963 from the rocket launch in Thumba. Aryabhatta, the first Indian satellite, carried experiments to study atmospheric science and astronomical objects. And then we have series of experiments which have gone into space to study either atmosphere science or space science, like astronomy or atmosphere science, like ROSC, C2, Indian X-ray astronomy, astronomy experiment, or SOX. But the first major planetary mission, I should say, is the Chandrayaan. Chandra and Yan. Chandra means moon, right? And Yan means spacecraft. So that's how the word Chandrayaan was spelled. And we all know that it was launched in October 2008. And after 16 days of journey, it reached moon on 8th of November. It carried 11 experiments on board. And you are seeing all these experiments on this right side cartoon. 3 of these experiments were being flown for the first time in planetary exploration. And they are all given there. I will not read all the names which is given over here, but except to tell you that if you look at this spacecraft, it was very busy. It's a busy spacecraft because we have 11 experiments on board. And I was directly involved with the SARA experiment, which has 2 sensors, CINA and SIP. Now, if you look at what kind of science has come out from Chandrayaan, there are more than 180 scientific publications which has come out from the Chandrayaan mission. But of course, the most important has been the discovery of water. And that has made a big impact in the whole world in terms of informing the scientific community that moon is not bone dry. There is water on the moon, and now we know there is ample amount of water on the moon everywhere. It is more in the polar regions, but it is scattered all over the globe of the moon. And that is a big discovery because water requirement is huge if we think about going to a settlement over the moon. There are many other science results. Some of them are listed over here, like talking about validating the lunar magma hypothesis in terms of telling how moon came into existence, many magnetosphere discovery on the moon, many craters, and volcanic activity. Now we know that moon is not dead. It is alive. There has been observations of volcanic activity, tectonic activities on the moon. And of course, many rallies, which we call as lava tubes, which came out of the volcanic flow on the surface of the moon, which probably can be used in the future for human settlement. So many science results, I just mentioned, some of them are shown over here, which made the cover page of the very important scientific publications. This is a slide showing the discovery of water on the moon, the science, and the GRL talking about, or Geophysics letter, talking about the discovery of mini magnetosphere. I like this slide very much. You know why? Because what you're seeing is how the Earth looks as you see from the. So this is an image taken by the Chandrayaan-1 telemapping camera. And this is on 22nd of July 2009. And that was an eclipse day. So our idea was actually to look at the shadow of the moon falling on the Earth. Okay. But unfortunately, July, you know, it's a monsoon season mostly. So you see a lot of clouds here. But you could still see the shadow of the moon falling on the planet. And the bottom, what you're seeing here is actually the part of the surface of the moon. And let me see whether this one can play of how the surface of the moon looks like. I don't know, you can confirm whether you are able to see this moving. So this is from, can you see this movie moving?
Arjit? Yeah, it is seen.
Okay, great. So this is actually the surface of the moon. Okay. And this is taken by Indian Chandrayaan-1 mission. Okay. You are seeing here, you know, a lot of undulations, bright patches, dark patches, and everywhere you see this kind of spots, they are all craters. So moon is actually full of craters. Craters inside crater, crater outside crater, either crater, other crater, jidhar dekho, crater hi crater. Okay. And craters of all possible dimensions are there. You talk about centimeter size, meter size, kilometer size, hundreds to thousands of kilometer size, you have craters. This is because moon doesn't have an atmosphere, and that's why everything falling on the surface of the moon creates a crater. Okay. I will now go quickly to Mangalyaan or Indian mom. Mom, हम लोग सब घर में माँ को बोलते हैं, right? Nowadays, all this young children, they call mother ko mom. Mom, what are you doing, right? So Indian mom is now around Mars. And, you know, it has been there since last close to 8 years. 7.5 years has already passed. We had the launch of this mission in November 5 of 2013. We reached Moon on 24th of September 2014 after 10 months of journey from Earth to Mars. And now we are orbiting around Mars. So this mission is still working, though the planned lifetime was only 6 months. Okay? This is how, just to tell you how did we undertook this kind of missions. We had the launch from Sharikota. We went around the Earth and became more and more elliptical in orbit, and finally departed from the Earth on 1st of December 2013. Why we did this was because we have to gain energy to escape the Mother Earth. So we need at least 11.2 kilometer per second, higher than that, to escape the Earth, right? Because 11.2 kilometer per second is the escape velocity for. And then when we went into an orbit, we knew where the Mars is. But then Mars is also moving around the Sun. Earth is also moving around the Sun. Mangalyaan is also moving around the Sun. So we have to did all the calculations possible to see that Mars is at the right place when the Mangalyaan is reaching the Mars. And then we got inserted around. Okay. And this is a very unique event, because India is the first country in the world to have the successful insertion of an orbiter around the Mars in the first attempt. No other country has done it. And that's why India has this rare feat. Now there are 5 experiments on board, 3 of them developed in Space Application Center in Ahmedabad. And Professor R.P. Singh is sitting there. He was instrumental in many of these instruments which are developed in SAC, particularly the Mars color camera, the methane sensor for Mars, and thermal infrared imaging spectrometer. We have an Lyman alpha photometer from Laboratory of Electro-Optics in Bangalore. And then the MENCA instrument, that is the Mars Exospheric Neutral Composition Analyzer, was developed in Vikram Sarabhai Space Center at Space Laboratory, where I was working. And all these instruments just weigh only 13 kg, whereas the total spacecraft mass is 1300 kg. So it is just 1% of the total spacecraft mass. So this is how the various instruments are mounted on the spacecraft. Many of these imaging payloads are sitting on one side, looking towards the Mars, including the lab. And MENCA is mounted along the plus roll axis, because MENCA is looking at the in situ measurements of the atmospheric gases present in around the Mars. This is how the Mars looks like from the MCC or Mars color camera. Okay, and you can see the full globe of the Mars. Why? Because of the highly elliptical orbit of the MOM, that it goes far away from the Mars and look at the Mars. So you get the full globe view. This is how it looks like in a different season. You can see the freezing happening in the north and south poles. So the top one is the north, the bottom is the south. And you also see surfacial features, canyons, particularly this one, which you will see it better somewhere else. Or you see Phobos. Phobos and Deimos are the 2 small satellites of Mars. And this is one of the pictures taken by MCC, where we see actually Phobos passing in the front of the Mars. Or the canyon, which I was just talking about, which is called as Valles of Marineris. This is actually the biggest canyon in our solar system. And here you are seeing, you are not able to see the canyon because it is filled with clouds and dust. So it depends upon the activity or the season of the Mars, that whether you are able to see the surfacial features or not. There are many science results which has come out. One of them I will just show over here, which talks about how the Mars atmosphere changes from carbon dioxide atmosphere to a oxygen dominated atmosphere. And this was observed by the MENCA instrument on the MOM, particularly in the evening sector of the Mars, where we showed that at about 250, 260 to 270 kilometers above the surface of the Mars, we have the carbon dioxide atmosphere converting to oxygen dominated atmosphere. And this is essentially happening because of the dissociation of the CO2 by solar ultraviolet radiation. We also discovered suprathermal argon, particularly in the exosphere of the Mars at an altitude of somewhere around 250 to 300 and above. But what does it mean? It means that we have atomic species or atomic molecules present in the atmosphere of the Mars, which are little hotter than the ambient. And if you have an hotter species in the exosphere of the Mars, it is quite likely that it will escape the planet. And that has implications for the escape processes and the atmospheric escape on the Mars. There are many features. One of them you're seeing over here. This is the Olympus Mons mountain. And the white thing which you're seeing on the left side of these mountains are nothing but clouds. So they are basically orographically controlled water clouds, which are seen formation, which also happens on the planet Earth. Deimos, another small satellite like Phobos, but is smaller than Phobos. And here, for the first time, you are able to see the Deimos from all sides. Why? Because we have a highly elliptical orbit around Mars. And you can see how the Deimos actually looks like from different viewing directions. When the MOM mission became very successful, then it happened on 24th of September of 2014. The next day morning, I got an email from my friend in US, and he was telling that MOM has become so famous that it has come on the Coke diet. So you are seeing actually a Coke diet, or Diet Coke, you can say, and the MOMs written over there. And Google, celebrated Doodle 1 month later on October 24th of 2014, and it basically celebrated the Mangalyaan. And Amul, very famous brand for all dairy products, it has come out with its own way of praising ISRO and Mangalyaan by writing as ISRO's cow Amul, ye cheez badi hai mast. Okay. And the pictures taken by this Mangalyaan has now come on the cover page of the National Geographic, talking about race to red planet, because it is India who became the first country in the world to have the successful insertion of an orbiter around the Mars. Remember that, okay? And realizing that, the government of India has put the Mangalyaan on the back of the 2000 rupees. I hope most of you must have noticed it. Those who have not, please notice it, that Mangalyaan is at the back of the 2000 rupees. Now, moving on from Mangalyaan to Chandrayaan-2 mission, you must be already aware about this mission. It has a launch in 2019, and this was a more complex and complicated than the Chandrayaan-1. Why? Because it not only had an orbiter like the Chandrayaan-1, but it also had a lander, which we named as Vikram, and a rover called Pragyan. And you all know what all happened with respect to when we did the landing on 7th of September. But the Chandrayaan-2 orbiter is in orbit around the moon, is working very well. There are 8 experiments on board, providing excellent quality of data. And this is actually enhancing the science which has come out from the Chandrayaan-1, because the instruments which are flying on the Chandrayaan-2 are much more advanced and much more sophisticated than the Chandrayaan-1 mission. We are now coming up with the Chandrayaan-3 mission, which is going to be a lander and rover, basically trying to fulfill what we could not do in the Chandrayaan-2 mission, particularly the soft landing, and then the rover coming out of the lander and moving on to the lunar surface. So we have instruments flying on the Chandrayaan-3 lander as well as the rover, and they are essentially meant to look at the elemental composition and mineralogy onto lunar surface. That is the rover instruments, the LIPS and APXS. LIPS stand for laser induced breakdown spectroscopy, and APXS stands for alpha particle X-ray spectrometer. So they are 2 different instruments, but both of them are actually essentially looking for chemical composition or elemental composition to look at the mineralogy over the lunar surface in situ. Okay, this is the difference. It is not remote sensing. They are just going down and then measuring it. That's why it is called in situ. Whereas the instrument on the lander is one of them is Chaste, which is going to be for the first time going inside the soil of the moon up to almost like 10 centimeters or below, and will provide you the temperature gradient of how the temperature changes as you go inside the moon. There's an instrument called ILSA, which is going to measure the seismic activity, and then RAMBA, which is essentially trying to provide you the plasma properties very close to the surface because it is sitting on the land. Some of those things which has come out from this mission, I'm just going to run through to give you a feel. You can actually watch the science results which is coming out from the Chandrayaan-2 at the ISRO's website, and the press releases which ISRO is doing often on these things. So this is actually a result from the terrain mapping camera, which is talking about the type of information which was getting from this kind of mission, particularly the three what you call viewing direction which it has, fore, nadir, and aft. One can actually generate the digital elevation maps, so you can get the topography of the surface of the moon in much more detail. And there's a crater. All of you must be aware about that. We have a crater on the moon called Sarabai crater, which is situated on the near side of the moon. That is the side which is seen from the Earth. Okay, so in the night, probably, if you look somewhere on the moon towards the your left side, you will see a small crater which is called a Sarabai crater. And this crater has been seen now very well with the Chandrayaan-2 terrain mapping camera. And if you look at that, you will find that this crater is about 8 kilometer in diameter and about 1.7 kilometer deep. So this crater can actually be seen by many of you, those who are, enthusiastic about looking at the sky, should try to figure out where the Sarabai crater is. We have fantastic information coming out from other instruments, including the OHRC, which looks at high resolution maps. I will show you one of them. This is the dual frequency SAR, L and S band SAR. So this is actually a hybrid polarimetry, decomposed images, which is not giving information of the surface, but beneath the surface, because these waves can penetrate beneath the surface of the moon and provide you information from few meters beneath the surface. So that is the advantage of the radio waves, which is available using this synthetic aperture radar in the L and S band. OHRC, as I was just mentioning, it is providing you highest possible resolution, spatial resolution information. Even talking about a small boulders which are 1 meter in height or so, and very small craters which are almost like meter in size. So now we have very high resolution information about the lunar surface from OHRC. And there's an instrument from PRL, which is developed by colleagues in PRL, called XSM, or Solar X-ray Monitor. And this is flying on the Chandrayaan-2, providing information about the X-rays coming from the sun falling onto the lunar surface, because there is another instrument called CLASS, which is looking at X-rays from the lunar surface. So the source of this X-rays from the moon is nothing but the solar X-rays which is falling onto the lunar surface, which we call XRF, or X-ray fluorescence. So those who are science students, or who are teaching science to the your students in schools, should talk about very specific things which is coming out from this kind of missions, so that the students also get excited. And this instrument is the most sophisticated instrument flying as of now around the globe, because it is providing you 1 to 15 keV X-rays coming from the sun every 1 second spectra. And it is much better than the GOES which you are seeing over here. And this is actually a instrument flying from NASA. And here you see how much better it is in terms of sensitivity, because it is able to pick very small fluctuations, almost like 2 order of magnitude better than what can be done by GOES. And there are many science results which has come out from this, but one of them is talking about micro flares which is happening in the sun. And these, about 100 of them have been seen since September of 2019. And they are actually happening at the time of when the sun is quietest in its activity. for almost like last 100 years, the sun was quietest in this period of November 2019 to almost like December 2020. And during that time also we are seeing very, very small flares are happening, but there was no instrument to look at that. Now XSM on the Chandrayaan 2 is able to tell about that. And that is one of the reasons probably which could be heating the sun corona to 1 million Kelvin. This is all science results highlighted. I will skip this. What next? We are now talking about a mission to actually study the sun. And this mission is called Aditya L1. Aditya means sun, right? And L1 is a location where it goes. So where is L1? Let me tell you first. L1 is a point between sun and earth. So in the center you are seeing a sun, and this blue color circle which you are seeing, filled circle, is the earth. So L1 is on the line joining sun and earth, right in front of earth, about 1% of the distance between sun and earth. Okay, so it is a point, or you can say location. It is not exactly a point because nothing can be stable if you put a point there. So the spacecraft goes around the L1 point. Okay, and as the earth is going around the sun, the L1 point also goes around the sun. So the beauty is you are able to see the sun continuously uninterrupted. Okay, and that's why it is a very important location or a vantage point from where you can see the or study the sun. So coming back to Aditya L1, this is a observatory going to be at L1 point, and where our focus is to understand, the corona, which I was just mentioning, 1 million Kelvin corona. So how the coronal heating is happening, how the solar wind, which is a wind coming from the sun, which you are seeing here, some kind of ejectas are coming out due to solar flares, and coronal mass ejections are happening. And then understanding the solar wind, temperature, anisotropy, distributions, both by in situ measurements and remote sense. So we have 4 instruments which are going to look at the sun from L1 point, and then there are 3 instruments which are going to sense the plasma which is coming out from the sun towards the earth. And the advantage of L1 point is that anything which is coming from the sun comes at L1 point first before it comes to the earth. So it becomes a kind of forewarning or a forecast of what is coming from the sun towards the planet Earth. So this is going to be a very important mission, and we have instrument going to observe the sun in the visible, in ultraviolet, and in soft and hard X-rays. And then we have instrument to look at the charged particles which is coming from the sun along with the magnetic field. In future, what we plan to do, we have now discussion going on about flying a mission to Venus, as well as the second mission to Mars. Now, Venus, as you all know, is a very important planet, a very different planet than any other planet in the solar system, essentially because the Venus is rotating very slow. It is taking almost like 240 Earth days to spin on its axis. So you can imagine that one night will be about 120 days. One day will be 120 days. Now compare that with Mars, which has almost like rotation as that of the Earth, about 24 hours, right? Both of this, Venus and Mars, are dominated by carbon dioxide, CO2 gas, right? But if you look at this picture, which I'm showing for Venus, you are seeing a lot of streaks. These are nothing but clouds, because this is not a picture of the surface of the Venus. We can't see the surface of the Venus in the visible light because it is opaque. And that's why the clouds are actually scattering back the radiation. That's why Venus is so bright compared to Mars. Okay? So Venus is very different. And these clouds, they are largely made up of sulfuric acids. And they're all coming for volcanic activity happening on the surface of the Venus, because the surface of Venus is also very hot. It is about 800 Kelvin. 800 Kelvin, or you can say about 450 degrees centigrade. Boiling point of water is 100 degrees centigrade. So it is much above the boiling point of the water, right? And the surface pressure is 90 bar. 90 bar, or you can say 100 bar. Okay. When you look at the Mars, it is 100 times smaller than the Earth. So the surface pressure of the Mars is about 2 order of magnitude smaller than the Earth, but on the Venus it is 2 order of magnitude more than that of Earth. Okay. But luckily, when you talk about Venus, as you go up in the atmosphere and you reach somewhere around 50 to 60 kilometers above this cloud deck or clouds which are seen, the temperature and pressure is almost same as that of the Earth or surface of Earth, about 1 bar and about 300 Kelvin. And that is the place where we are now thinking probably there could be an existence of life. And that's what people are talking about, particularly after the discovery of phosphine in the clouds of Venus. Okay. So Venus is a very different planet than Mars or Earth, though they are all within the what you call the category of planets called terrestrial planets. And also that Venus clouds, which I'm just showing over there as a picture, and the streaks which are seeing, the clouds move very fast around the Venus. And that's why, they are seeing as a streaks. And they complete one rotation around the Venus in 4 days, whereas the Venus itself is taking 240 Earth days. So you can imagine that there is a super rotation of the atmosphere happening in the case of Venus. Okay. Mars, as we all know, is also a very important planet and very interesting planet, particularly because we are all interested to explore Mars in more detail, because we can do easily landing on the Mars, which is not possible on Venus because the temperature is very high on the surface. And also very interesting because there could be a possibility of life, because we now know water has existed on the surface of Mars. So these are the 2 planets which we are talking about going in future, and particularly trying to understand it with respect to what we know about the planet Earth. And when we go to this kind of missions, we can also explore on the way any comets or any asteroids which is coming on. So that is how the future of the planetary exploration is. And I would request all the teachers who have joined us live on this platform in this talk to tell your students about the space exploration program of India, and talk about the various planets which have been visited by spacecraft developed in India, and some of them are actually now working around, like Moon. We have Chandrayaan 2 operating. Mars, we have Mangalyaan or the MOM mission. So with this, I will now talk a little bit about exoplanets, because we are talking about planets in the solar system. Exoplanets are the planets which is going around the other stars. And PRL, that is the Physical Science Laboratory, is the only laboratory in India which has discovered exoplanets, or you can say the first exoplanet from India. This is a discovery made by a 1.2 meter telescope at Mount Abu using an instrument called PRS, which was developed indigenously at PRL, and it has discovered a sub-Saturn size exoplanet, which is almost like 6 times the Earth mass, Earth radius, and 27 times the Earth mass. And the technique which has been used, to discover this is called radial velocity. Essentially, what is happening is we look at the light coming out from the star, but if there is an object going around it, there will be small displacement of this star, okay, and which will in turn give a red or blue shift of the light coming, and that is what is studied using this instrument called PRS. Okay, and using that, we can very precisely say that it is a planet and nothing else. This was done to discover this planet, which is almost like slightly bigger than the size of the Neptune, but smaller than the size of the Saturn. And this discovery has been hailed by our Prime Minister, Narendra Modi, which tweeted, this was done in 2018. And he says, immensely proud of our scientists who created history by discovering a sub-Saturn sized planet 600 light years away from Earth. Congratulations to them. The discovery puts India among the select countries, because India is one among the few selected countries in the world which are discovered exoplanets. And very recently, we have discovered another exoplanet, which is actually inflated hot Jupiter, which is much bigger than the size of Jupiter, but its density is smaller than that of Jupiter. So it is inflated and it is very hot because it is very close to the star itself. I'll talk to you later on sometimes, or you can actually see the website of ISRO or of PRL to get more information on this. So with this, I would like to also suggest you and invite you to visit Mount Abu Observatory, those who are staying nearby, at least, or those who can visit Mount Abu. Go to this observatory called Mount Abu Observatory at Guru Shikhar. And there's another telescope which is coming up now, which is a 2.5 meter telescope. So this is the older telescope, which you see over here on the left side. And on the right side, you are seeing here is another big telescope, which has a dia of 2.5 meter. So it will have a sensitivity which will be about an order of magnitude better than that of the 1.2 meter telescope. And this is going to really help us in discovering exoplanets which are much smaller in size compared to what we could do from the 1.2 meter telescope. So with this, I would like to thank you all for listening patiently. And if you get time, do visit PRL, do visit Mount Abu, or even the Udaipur Solar Observatory. Thank you. Thank you very much.